Okay, so um, I might tell you this type of information. I might tell you what a factor of a polynomial is. And what that means is we can do a division on it. So set up the division. This is not really that much different from what we've done so far today, but I just wanted to show you that this might be a different type of framing that I might give you in the question. So then let's do the division. We're going to have a 2x squared here. That's going to put a negative 6x squared here. I don't want a negative 6x. I want a negative 6x squared. I want a negative 5x squared. So I have to add an x squared here. Then I'm going to have to put an x here so that x times x gives you x squared, which makes me have a negative 3x here. I don't want negative 3x though. I want 6x. So what do I have to add? I have to add 9 more. Okay, so then I have to have a 9 here, which means that I have to put a negative 27 here. And now this matches this, and so that's how you know that I'm done. Let's rewrite what we get then. What we have is, the question says rewrite the polynomial p of x as x minus 3 times another polynomial. So here it is, x minus 3 times my other polynomial is what I got at the end when I was doing my division. That's the quotient when I do my division. So that's going to be 2x squared, squared, plus x plus 9. So I can rewrite p of x this way. Here's one more type of way that I might give you some information about this polynomial, about q of x. I'm just going to give you a little reminder that this is sort of the way that we would write the factor theorem. Remember that if q of a, then x minus a is a factor of the polynomial called q of x. So let's rewrite and let's use a polynomial, or let's use division. So that means that if q of negative 2 is 0, means that x plus 2 is a factor. This right here is is the most critical thing that you can get out of today. You need to be able to use the factor theorem to interpret a 0 as a factor. So let's rewrite it. We're going to divide by x plus 2 here. Sorry, I'm going to do it in black. X plus 2. And we're going to put q of x inside the box. So got to have my 1/2 x cubed there. And I'm going to put a 1/2 x squared here because that will match with this to give you this. So multiply with it. Then I need to do the multiplication between 1/2 x and 2x, and I get, and 2, excuse me. So then I get x squared. I don't want x squared. I want negative 3x squared. So how do I get there? I subtract 4 x squareds. Then I need to have a negative 4x here, which means I have a negative 8x here. But I don't want negative 8x. I want negative 18x. I feel like I'm Charlie in the chocolate factory. I don't want that. I don't want that. Okay, so then I have to subtract off 10 x's to get to this point. So then I have to have a negative 10 here, and then that makes me have negative 20 here. And so remember, this matches this, and so that means that I'm done. So I can rewrite q of x as 1/2 x cubed minus, I'm sorry, I should rewrite this like this. Sorry. Q of x is x plus 2 times 1/2 x squared minus 4x minus 10. Okay, so this is sort of the ultimate result of today. You can rewrite now, if you know a factor of a polynomial given a piece of information. I'm going to give you a piece of information that you will maybe have to turn into a factor like we did right here. then you can rewrite the polynomial as a factor times some other stuff. Okay, so I'm just going to give you a little preview of what we're going to do tomorrow, where I'm going to go through this a little bit quickly. If you are like, oh yeah, this makes sense, then awesome, you're kind of ahead of the game. If you're like, I don't quite get this yet, that's totally okay. We're going to have more time to work on it. This is the graph. The red graph is the graph of this polynomial. We'll call this p of x. So what we know here is that if you put in -2, you get 0 out. So p of -2 is 0, which means that x plus 2 is a factor of p of x. I'm going to do the same exact thing with this other place where it crosses the x-axis, and it looks like this is the point, positive, it's positive. So I'm just going to write 1.50. So we can write the same thing. We can say p of 1.5 equals 0. So x minus 1.5 is a factor of p of x. All right, so what we're going to do is we're going to start by let's divide p of x by x plus 2 first. So p of x is going to go inside the box, so I want my 2x to the 4th right here. I'm going to go through this quickly. This should be a review at this point in today's lesson. So here we go. These two together give you 7x cubed. That means that I'm going to put a 3x squared here. That means that I have to have 6x squared here. This together with this add to 21x squared. So what do I have to add to get there? I have to add 15 x's, x squareds. That means that I have to have 15x on the top. And so then I have to have 30 x's here. I don't want 30 x's, I want -6 x's. So I have to take away 36 x's. These two together give you -6x. What I'm left with on the top is I have to have -36 here, and that multiplied by 2 is -72. This matches this, so now I am done. What I can do is I can now write p of x as x plus 2 times 2x cubed plus 3x squared plus 15x minus 36. But here's the next thing here. I also know that x plus 1.5, x minus 1.5 is a factor of p of x. Now what we're going to do is we're going to take this and divide it by x minus 1.5. Going to have my 2x cubed here. That means I have to have 2x squared here. Then I'll have 3 minus 3x squared here. I don't want that. I want positive 3x squared. So I have to put a 6x squared here. These two together add to this. That means that I have to have a 6x here, which means that this has to be -9x. But that's not what I want. I want 15x. So I have to add 24 x's. So then I have to have 24 here. And then this makes this -36. And so then, just to confirm, this matches this, and that means that I'm done. Now what I can write is I can say p of x is equal to x plus 2 times x minus 1.5 times my quotient from the second division, which is 2x squared plus 6x plus 24. Now this, original question was, what happens when it's equal to 0? And so what I'm doing is I'm trying to solve the equation equals to 0. Then I could apply the zero product property, this, and this. Remember, this was our goal, get a quadratic and this together. Then I'm not going to do this right now, but we could apply the zero product property and get our solutions. Okay, that's enough information for today. I'm sorry that this was a little bit rambly, a lot of stuff going on, but this is just really important stuff, and it's really kind of important to get a lot of practice. So that's that for today. Have a great day, and see you next lesson.